All right, so the purpose of this video is to explain how to solve quadratic inequalities. Now, graphing quadratic inequalities, which is what the first video was about, that happens when you have a quadratic function of two variables. So you have y and x and an inequality. So you put that on, a Cartesian plane, dotted solid, all that stuff. When you have a quadratic inequality like this that has only one variable, the process is a little bit different. You're actually trying to figure out what x itself should be. So what I'm going to do with this is I'm going to solve it sort of like it's an equation, and then I'm going to make an adjustment at the end for it being an inequality. So let me explain how this is going to work. So if I were trying to solve this, the first thing I would do is get everything on the same side. Now, I could solve this by factoring, I could solve this by completing the square, I could solve this by quadratic formula. I know that this is going to factor just by looking at it. I want two numbers that multiply to give me 5, that add to give me -6. So those two numbers are -5 and -1. Now, the two numbers that would make this equal to 0 are x equals 5 and x equals 1, right? But I don't want to know what makes them equal to 0. I want to know what makes this whole thing less than 0. So what I'm going to do here is a process you'll see a lot in math, both in this class and in later classes. I'm going to make a number line. Now, on this number line, I'm going to place the two numbers that I just found that would make it equal to 0. The reason I mark those is because if you look what this inequality says, it says I want x minus 5 times x minus 1 to be negative. And so I want to include the places in the answer where that product is negative, but not the places where it's positive. So the places where it switches from positive to negative or vice versa are the places where it equals 0. So that's why we want to find where it equals 0 and put those in the number line. Now, every number in each of these three intervals will either make the whole inequality positive or the whole inequality negative. And the way we figure out is we choose a number in each of the intervals. It's kind of like doing the test point, except we're doing test numbers here. So I'm going to choose the interval of less than 1, the number 0. So when I plug 0 in, now I could plug it up here, I could plug it in here, or I could plug it in here. And really, it doesn't matter which one you do. So when I test 0, we'll just use the original just to make sure. I would get 0 minus 6 times 0 is less than -5. And so I want to know if that's true. Is 0 less than -5? And of course, that is not true. So that means that this interval does not work. Now, if I try something in between 1 and 5, like 2, if I plug in 2 into the inequality, I would get 4 minus 12 is less than -5. So -8 is less than -5, and that does work. So every number in that interval works. And then I want to test a number bigger than 5, say 6. So when I test 6, it says test, I will get 36 minus 36 is less than -5, and 0 is, again, not less than -5. So the interval that is my answer are these numbers in between 1 and 5. So the way I like to write that when I have an interval that's got numbers between it is I like to write what's called a tripartite or three-part inequality. I write 1 is less than x is less than 5. Now these are just less thans without an equal to because the original didn't have an equal to sign on it. If it had, we would have included an equal to sign on the answer. So I'm going to do another problem like this, but has a slightly different application. So another quadratic inequality to solve. So I'm going to get everything on the same side, just like I did before. And let's make that one equal to just for fun. So this time it doesn't look like it's going to factor easily. So I'm going to do the quadratic formula. For AC, that'd be 32 all over 2 times 1. So I would get -4 plus or minus the square root of -16 all over 2. Now we know from what we've just talked about that these are going to give me complex numbers that have imaginary parts, right? So these complex numbers here, when I go to draw the number line that I did in the last step, this is a real number line, not a complex number plane. So if I get imaginary answers here, that doesn't mean there's necessarily no solution. That means there is an option of no solution, but it could also be that everything that's real works. In other words, back on the previous example, when we had the line that was divided into 3 parts and some worked and some didn't, this time the line hasn't been divided. It either all works or all doesn't. So you still choose a number from the interval, but there's only one interval to test. So I'm going to choose 0. So when I do 0, I get 0 is less than or equal to -8, which is not true. So that means that nothing on this line works. If I had plugged in 0 and it had been true, then the answer would be all real numbers. But as it is, there's no solution to this inequality. So to recap, solve it as if it's an equation, put those answers on the number line, test numbers from the intervals in between in your inequality, and whatever works is part of your answer, whatever doesn't isn't.